I'm going to run through some example problems from section 4.5. So, first thing is identify the period and the amplitude. Now, amplitude is easy, it's just the vertical stretch. So the amplitude in this case is just the multiple 3/2, or I suppose 1.5. So this multiple, though, for the period, right, the b as we commonly call it, is equal to 2 pi divided by the period, which means if we know what b is, which in this case is pi over 2, remember this also means that period is equal to 2 pi over b, then we're talking 2 pi divided by pi over 2, which is the same as multiplying by the reciprocal, so 2 pi times 2 over pi. The pi's cancel, 2 times 2 is 4, so the period would be 4 units. Describe the relationship between the graphs considered amplitude, periods, and shifts. So looking at this, I see no shifts at all, so no phase shift between these two. They're both just 4x. I do see because I suppose they talk about shifts there. I do see a vertical shift, so no horizontal shift, no phase shift, but I do see a vertical shift. So when we're talking about this would have an amplitude of 1, and this would have an amplitude of 1. I can tell because there's just a 1 in front of both of those, right? The period of this is, well, that's b, right? So the period is equal to 2 pi over whatever b is, which we reduce to pi over 2. And if you look, the period for this is going to be exactly the same. So as we're comparing these, we know that they have the same amplitude and period. However, this has a vertical shift of down 2 units. So we say the midline is at -2, or it's been shifted down 2 units. Okay? That's what the relationship is. So we're talking about two graphs that look exactly the same. This one's just 2 units lower. Okay. Describe the relationship between the graphs f and g. Consider amplitudes, periods, and shifts. Okay, so the amplitude, as we're comparing it, both of these appear to be stretched vertically the same. In other words, the amplitudes are the same for both of these graphs. Okay. The period. Well, the periods are different. So g would appear to be repeating itself in that interval right there. Now this is 2 pi, so I got to assume that that's pi units, right? So I would say g has a period equal to pi units, right? Whereas f has a period that is equal to, well, f, if you look at it, comes first full circle. That's this lower graph here. It takes 2 pi units. So you could say f is twice as slow, or g is twice as fast, right, if you will. In terms of other shifts, I really don't see anything. So the only thing that's changed is the period, and the amplitude is the same. So the big difference here is just the period in these two graphs. So for these two graphs, I think you could argue safely that, well, look, this one goes full circle, right? Half a circle plus half a circle, this red portion, in 4 pi. And the periods are the same for both graphs, yes? In terms of amplitude, from the midline, this has been stretched up 1, which means its amplitude is equal to 1. And if you look at this, from its midline, right, if you were to draw a horizontal line here, it's been stretched up 1, so its amplitude is also 1. So the amplitudes are the same, right? And the periods are the same. It's just that g has a vertical shift of up. Well, how do we do this? 1, 2 units, right? So you can track where the midline goes. Or if you take a look at the max and you compare it to the max, this has been shifted up 2 also. Or the min and the min, whatever's more convenient to actually measure. Okay, sketching a graph. So sketch a graph of f and g in the same coordinate plane, include 2 full periods. All right, well, let's start with 1 full period and see how this goes. First off, we need to figure out, so this has an amplitude of 2, and here this period is equal to, so the period is equal to 2 pi over 2, which is pi, right? So f is a cosine model. It's stretched, so it's going as high as 2, and as low as -2. And cosine, as we know, hasn't been reflected or anything, starts at 2. It's going to go down. It's going to repeat itself every pi units. So let's go pi over 2 and pi. So this is going to get a bit tricky because it's going to start here, right? So we'll use blue for this one. It's going to start here. It's going to go down to -2 and then go back up all the way up to +2. And it's the halfway point between there is going to be about my pi over 2. So what's going to happen is it's going to actually go through like that, more or less, right? And then it's going to do that again until it hits 2 pi. And now we know that halfway between here and here, that's 3 pi over 2, okay? Please note that if this thing is repeating itself every pi, if you cut that into fourths, right, halfway, that's our pi over 2. This portion would be pi over 4. Pi divided by 4 is pi over 4. And this is the 3/4 pi, okay? And this would be pi over 2 or 2 pi over 4. Okay, opposite cosine 4x. So this opposite, this negative, represents a, well, hopefully you remember from our transformations, this has been reflected over the y-axis, right? So this has been reflected over the y-axis. Now, the number in front of here is still 1, so the amplitude is still 1. So it's a cosine model, which normally starts up high and goes down low, except it's been reflected. So instead, it's going to start down low and go up high. Now, this thing has a couple other things going on. This has a period equal to 2 pi over 4, aka pi over 2. So this thing is going to repeat itself in pi over 2 units. That is twice as fast as the other graph. So what's going to happen by the time it hits pi over 2, it's going to have gone around once. Now, let's start to think strategically here. We'll go with red for this graph. It's going to start not at +1, but -1. Under normal circumstances, cosine would start at 1 and go down, right? Except now it's been reflected, so it's going to start here and go up. And I'm going to have to get it to go start at 1, go as high as, sorry, -1, go as high as 1, and go as low as -1. It's all going to have to do it in, that's pi over 2 radians, so it's going to go like that. And it's going to do the same thing by the time we hit pi. It's been very compressed. And it's very hard to do that, but this generally shows us that what the amplitude is. It's going high and low as 1 and -1. Has been reflected, which is why it's starting down here. Okay, sketching this. Use a graphing utility to verify. All right, so include 2 full periods. So this is a little easier. So what we're going to do is we're looking at something that has an amplitude of 3. There is no vertical shift, so it's going to be centered at 0. And it's going to go as high as 3 and as low as -3. It's cosine. It's not been reflected, so it's going to start up here. And this x is 1, which means that the period is equal to 2 pi radians, right? So what this means is normally it would start up here, go down, come back up, and 2 pi radians, right? Except it's been shifted pi over 2 units that way. Okay, so there's a couple different ways to do this. I'm going to go easy. If I think about it, what is normally 0 would be here, but I'm going to shift that pi over 2 units. So what's going to happen is this is going to be sitting here at negative pi over 2, and it's going to start at 3. Then what is it going to do? Well, it's going to still take 2 pi radians, right? Which means by 3 pi over 2, negative pi over 2 to 3 pi over 2 is, right, 4 pi over 2 or 2 pi radians. This thing is going to start and stop at 3, right? It's going to go down, come back up. Now, if we think about halfway, that's at 0 when it hits 0. This is at, what is that at? 0. Oh, well, that's got to be, well, this is pi over 2 where it hits the negative, right? And then this would be pi radians. So it's split into fourths. And then it's going to do the same thing. So from 3 pi over 2, we add 2 pi. So we add 2 pi plus 2 pi, aka 2 pi is the same as 4 pi over 2, right? Because this is over 2. So this would be 7 pi over 2 is what this would be, right here. So 3 pi over 2, 4 pi over 2, aka 2 pi, 5 pi over 2, 6 pi over 2, aka 3 pi, and then 7 pi over 2, right? Use the graphing utility to graph the function, include 2 full periods. All right, well, let's list it all off. We have A for amplitude, we have B for period, or the shift, so let's just go with period. Just go straight to period. Any phase shift? So there is no vertical shift. And what is the phase shift? Now I'm going to rewrite this such that the 2/3 is factored out. So what I need to do is take pi over 3 and divide it by 2/3, which is the same as saying pi over 3 times 3/2, which is the same as, well, the 3's cancel out, pi over 2. So this has been phase shift, right? Is that away pi over 2 units, right? Okay, so the amplitude is 4. The negative does not affect the amplitude, that's just the stretch, but it does affect what the shape, well, where it's going to start, okay? Under normal circumstances, sine looks like this, right? This would be sine. What does reflected sine look like? That is, what would negative sine look like? Well, the exact same thing except reflected, so if they're already on the x, so it would look like this instead of, let me back that up. Reflected sine would still start at 0, but it would go down first, then up. So you can see that this has been reflected over the axis. That's what that negative is going to do. Okay, now the pi over 2 is kind of the hardest thing, so let's get creative here. We know that normally at 0, this thing is, because it hasn't been shifted vertically, it's going to go as high as 4 and low as -4, right? Except it's been shifted pi over 2 units this way. So it's actually going to start at pi over 2, right? Because normally it would start at 0, think reflected sine, and then go down. But now it's going to start at pi over 2 and go down. So what is the period? So we actually haven't figured that out. It's going to be 2 pi divided by 2/3, aka 2 pi times 3/2, which means we're looking at, well, the 2's cancel out. It's going to be 3 pi. So under normal circumstances, this would take 3 pi radians to keep going, right? So 3 pi radians, by the way, that's the same as 6 pi over 2, right? Which means that we're, isn't it? Yes, 6 pi over 2, which means we're talking that, let's just arbitrarily say 7 pi over 2. What's the difference between pi over 2 and 7 pi over 2? 6 pi over 2, or 3 pi, which is our period, right? We know that this thing is going to go down and come up. And it's going to go down, come up. They do want us to graph 2 periods, right? Where would this be? Well, it's 7 pi over 2, so pi over 2 to 7 pi over 2 is 6 pi over 2. 7 plus 6 was 13 pi over 2. Okay. So this could be our different periods. This would be our 2 periods of that graph. It's probably the easiest way to sketch that. All right, find an equation for this, and they want us to use a cosine model. Okay, so taking a look at this, it's starting at a low value and going up. So we know normally cosine, right, looks like this, starts at high and goes low. So this, however, would be what would happen if I reflected cosine. So it looks like I'm starting at a low point and going high, which means I'm going to have a reflected cosine, so it's going to be y equals the opposite. What is the amplitude? So here's where we need to read our scale. So this says -6, that's 1. So 1, 2, 3. I would say that that's right around -3.5. That is what? -4. And that is -4.5. So the distance between -3.5 and 4.5 is 1, but the amplitude would be half that distance. Or how far is to go from -4 to -3.5? It'd be half. So the amplitude of this graph is equal to 0.5, right? So then cosine. What is the period? Well, let's trace it. We know that the period is what? It's going up, down, and then gets back to its minimum. That's one period, right? And then it does it again. So it's gone twice in 4 pi radians. 1, 2. So it looks like the period of this is equal to 2 pi radians. Because to go full circle, it's going at 2 pi radians. So that means that the multiple here is just 1, so it's just going to be x. And now comes the fun part, plus d. This is centered, right, here at -4, so that would be a -4, okay? And that would be that. Okay, of this form, a equals sine bx minus c. So let's figure out what a is. First off, it would appear to me that this is going as high as, let's see, it's 1, 2, and low as -2. Now, if you take the average, that is 2 plus -2, and divide by 2, you get 0/2. That would be the midline. So if you take the max plus the min and divide it by 2, that tells you the vertical shift. Now there is none, and we don't expect it, right? In that case, it's 0. However, if I were to take the difference between these two, so the max minus the min, and cut that in half, that would give me the amplitude. In other words, 2 minus the -2, which is a fancy way of saying 2 plus 2 is 4 divided by 2, means the amplitude is equal to 2. And you can also tell pretty easily by looking at the graph. How often does this repeat itself? Well, it's going down and up and there in 1, and then it's doing it what? So that's 2 pi. So it looked like it's going around 1.5 times in 2 pi radians. So what would that period be? Well, that's a bit tricky, isn't it? So it's going around 1.5 times in 2 pi, right? So how would we accelerate that? Well, just like if we had this b equaling 2, right? That means it's going twice as fast. But here it's only going 1.5 times as fast, which means that we have our amplitude, which is 2. We have our cosine. The multiple b is going to be 1.5 because if you take a look, 2 pi divided by 1.5 or 2 pi divided by 3/2 is maybe a better way to put that, then that ends up being 4 pi over 3, which is a bit more than 1 pi, which is what this is. Okay, so it turns out that this period is 4 pi over 3. And how I can tell is because I just counted, it looked to me like that's 1 revolution, that looks like half. It's only going from max to min in 2 pi radians. Okay, so it's going around 1.5 times. Another way to do it would be to find measures that we could easily match, like the distance between here and here, peak to peak, or from one 0 to the next 0. But either way, you can figure out that it's going to end up being 4 pi over 3 is the period, so the multiple is 1.5. Now, is there any shift? I see none, so I just leave it. So there's no phase shift, no shift from a normal cosine graph. Oh, I'm sorry, this is supposed to be a sine. So actually this would be cosine. So what am I going to do? So if this is cosine, I want to make it sine. There's a couple of options. Normally, this would be sine right here, right? I'd want to shift this way, right? So I'm taking what is a regular sine graph, and it turns out I'm shifting it that way. So it'd be 2 sine 1.5 x. Now I want to shift this thing. How far do I want to shift this thing? So I know that this is split up into fourths. So it means that this piece right here, if I'm thinking about it, I'm going to take my 4 pi over 3, which I know to be how long it takes to go around once, right? I'm going to divide that by 4, which is the same as saying 4 pi over 12, aka pi over 3. So I know that what's happening is this is happening at 0, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, right? Which means that I want to take, now I want a sine graph, right? So I want it to start here and go up, right? That's where sine normally starts. So I want to take that sine graph and I want to shift it back pi over 3 units, okay? So the key thing here is I took the period and divided it by 4 to figure out how often it's changing, because I have this peak here. So I take my sine and I shift it pi over 3 units that way, which means it's going to be plus pi over 3. But remember, if I do it that way, it's going to be plus pi over 3 that way, right? And they want it bx minus c. It's okay if it's plus. But what I need to do is 3 halves x, right? Plus, so this is 3 halves times pi over 3. So 3 halves times pi over 3. So that's plus pi over 2. These two are the same, and I'd be fine if you just left it like that. In fact, that's a little clearer, but this is also acceptable and fits how they want you to write it. Okay, so this last one is an example of how we can use this to represent the behavior, in this case the consumption of diesel fuel. So C is the number of gallons, right? And it seems to be fluctuating. Now, T is the time of days, T equals 1 corresponds to January 1. What is the period of the model? So B, right, B is equal to 2 pi over 365, which means it's equal to 2 pi over the period, which means the period has got to be 365, and because T is in days, it'd be 365 days, aka 1 year. So if you think about the consumption, would the consumption depend on where you're at in the season, right? And so would you expect it to be a periodic, right? Sometimes they're called periodic models, that's repeating itself with a certain period, right? So yes, is that what you expected? Well, maybe not strictly speaking, but year to year, would you expect the consumption rate to be about the same? Assuming that there's not a major variation in, say, I don't know, temperature, maybe it's, you know, the weather conditions, or maybe we don't have that, we have the same tractor or something like that. So what's the average daily fuel consumption? So if you think about this graph, this is a sine model, so it's going up and down and up and down, but it is centered at a certain value, and that is why sometimes this is referred to as the average. So that would be the vertical shift, which would be 30.3 gallons. So on average at 30.3 gallons is what your consumption rate is, but it goes up or it goes down. We would assume maybe depending on the weather, right? So use a graphing utility to graph the model, and then use the graph to approximate the time of the year when the consumption exceeds 40 gallons per day. So what I've done is I've prepped a graph here on Desmos. Let me bring that over. And I've graphed this, and I've also graphed the line y equals 40, because if I'm looking at this, this represents my fuel consumption, and where this graph crosses, right, in this case 123.875 and 252.247, that's where that consumption rate is 40 gallons, okay? So what does that mean? Well, it means that about 124 days in and 250, so day 124 and day 252, so day 124 and day 252 are when, so that'd be the two, because T is in days, right? 124 days in, so that's what? 30 days is a month, so that's about 4 months, so that's April sometime, right? And then this would be, well, more than that. But those are the two times when you see that, okay? When they're equal. So that concludes the examples.